In this video, we'll explore Ferrofun. From our initial testing, all the way to our finished demo. Now for some background on the project. We're a 4-student team all enrolled in the course Introduction to Rapid Prototyping in Physical Computing at Cornell University. At the beginning of the semester, we had no experience with rapid prototyping, physical computing, or hardware. We had to commit to a project within the first few days of the class and trust that we would develop the skills needed to complete our project over the semester. The inspiration for our project came from Ferrofluid, a clock that uses Ferrofluid to display the time. Another inspiration and resource was the YouTube channel Applied Procrastination, in which 2 students document their build of a Ferrofluid display. These were some of the first sketches done of our prototype. They were very simple, as we were not familiar with any of the hardware we were going to use yet. For our initial testing, we used an electromagnet and a neodymium magnet to test how far the ferrofluid could move horizontally and vertically, and we settled on 1 inch in each direction. For our electromagnet grid, we created our own electromagnets by coiling 30-gauge magnet wire around iron bolts, about 1,000 coils each. We soon learned of MOSFETs, transistors that we could use with our microcontroller to switch the magnets on and off. From there, we were able to build our initial prototype. 4 electromagnets turned on and off by an Arduino microcontroller, manipulating ferrofluid. We learned to use CAD software in class, and were able to laser cut a wooden board to hold the electromagnets. We were also able to model and 3D print a stand to hold the grid up vertically. Constructing a tank for our ferrofluid display proved to be harder than we originally thought. We started by creating a small test tank. We weren't able to clean the inside of it very well, and as you can see, that caused the ferrofluid to stick to the glass of the tank. We quickly discovered that ferrofluid stains and sticks to everything, including floors and hands. For our final tank, we used the flower vase purchased off of Amazon. We were sure to clean the inside of the glass thoroughly with vinegar before we let the saltwater brine sit in the tank for a few days, ensuring it coated every surface of the glass to prevent sticking of the ferrofluid. The lid to the container was modeled using Autodesk Fusion 360 and 3D printed. The suspension fluid used in the tank was a mixture of distilled water and kosher salt. In our first attempt of adding ferrofluid to our brine solution, the ferrofluid just floated to the top, indicating that we had added too much salt to the solution. After diluting the brine with some more distilled water and letting the tank sit for a few days, we had a tank ready for testing. Each magnet was connected to an IRF 520 N-channel MOSFET, and overall we had 4 9-volt 1.5 amp power supplies powering the magnets. Due to time constraints, we decided against soldering and went with jumper wires and electrical tape to connect the thin magnet wire to the breadboards. This meant that our connections were not very reliable and were not permanent, but that was okay because this was just a prototype. We were finally ready to combine the tank and the grid of electromagnets. This final system was controlled by an Arduino Mega. The final presentation took place at a children's museum, and the kids had a lot of fun playing with the ferrofluid tank and magnets. And we were finally able to debut our prototype.